Okay, welcome everybody. Thanks for coming to this session on organizing the data lake. My name is Mike Ferguson. For any of you here who are Irish, you might notice my accent. I'm from the north of this wonderful island rather than the south, but I live, of course, in the UK. A little bit about me to get started. My background is about 34 years in the industry, hence the grey hair, but at least I have some. My background is I started out as a DBA, and then in the 1980s I co-founded a company with two gentlemen who really changed computing, Dr. Ted Codd and Chris Date. You may, if you know your computing history, know Dr. Codd was the guy who invented the relational model. So all relational databases are built on that. And so I spent 4 years there before heading off to Los Angeles to become a chief architect on the Teradata database in '89, and worked there for about 3.5 years before setting up an industry analyst firm based in the UK on BI and analytics and data management. I've been there ever since. So, okay, I want to talk, I haven't got a lot of time, I want to talk about really the trends going on here at the moment, the data integration complexity that's emerging, the fact that a lot of companies are experiencing silos of data management going on at the moment, and why the costs of that are sort of spiraling a little bit out of control at the moment. And you know, is there another way around this? So I want to look at a kind of new approach to kind of governing and managing that, and introduce what I call a data reservoir, and we'll get on to data lakes versus data reservoirs later. And then start to look at how these work and how we can potentially produce new kinds of insights from a data lake or data reservoir environment that can map into something that can be made sense of alongside all of the other enterprise data which is there, which of course is mapping that into a kind of common vocabulary, and then talk about the emergence of key technologies in this area, like information catalogs. And I know there's been several sessions on that kind of idea going forward. So if I look at pretty well what we've ended up with so far within the analytical space, it's gone way beyond data warehousing. It's now out into multiple analytical platforms. And what we've ended up with is different kinds of analytical workloads running in different analytical platforms. Some of them optimized, say, for graph analysis, like a NoSQL graph database, maybe like GraphLab, or on a smaller scale, I guess you could go down to Neo4j. We can look, of course, at exploratory analytics on big data environments with Hadoop, and of course, machine learning and graph analysis with Spark. Of course, we've been doing machine learning in a data mining circle on data warehouse appliances for many years on structured data, but now we're talking about broadening that scope. But the bottom line here is we've got streaming data, we've got data at rest in multiple places, and we've got a broader analytical ecosystem. And of course, we can't forget master data, because a lot of us are working on customer engagement, which is often taken from, attached to master data in some capacity. But if you look at what's happening around data management in this ecosystem, it's got a lot more complicated than it ever was before. It's not just left to right populating a data warehouse anymore from OLTP systems. What we've now got is a whole range of different paths in which data is flowing. It's flowing, into Hadoop, being processed there, passing it on into data warehouses. We're archiving from data warehouses into Hadoop. We're going in capturing data in NoSQL data stores into Hadoop. We're producing MDM systems. We're still doing data warehousing and data marts. That hasn't gone away. So, and I'm not even looking at cloud here, which could equally be taken into account as well. So this is just a very high level, simplified view of some of the data flows going on in this ecosystem. But the problem for me with all of this is that what we've got going on within that ecosystem is a bunch of different tools and potentially a bunch of different silos going on. So for example, we could have data management to populate, say, a graph data store, and loading up that might just be loading it up using commands from a particular graph database. On Hadoop, we can load data into Hadoop a whole raft of different ways. I can flume it in, I can scoop it in, I can HDFS, DFS, put it in, on the command line. I can use ETL tools to do that, all kinds of ways. And so there's just within the Hadoop space on its own, there's multiple ways. We can NiFi it in, as we've seen with HDF this week as well. On the data warehouse, of course, that's probably more stable, nailed down environment, but truth be told, we've probably got multiple data warehouses. How many of you have got multiple data warehouses out there today? Probably quite a lot of you. So maybe multiple tools even running across to that. And of course, I can go to data warehouse appliances and MDM. And so before you know it, you can get into multiple silos of data integration going on here, potentially with different technologies. And yet the deluge is still coming at us. All kinds of new data sources pouring into the enterprise. And the real challenge is becoming, can we keep pace with the rate at which business wants to consume data? And I think what's become pretty clear, at least in several of my clients going forward, is that IT is becoming a bottleneck and not being able to provide sufficient resources to get data in on time into these environments and to process it all. And so business is knocking on the door and saying, let us in. Let us get involved in gaining access to data and participating in that. And so what we've seen is an explosion of self-service data integration and data preparation tools. New vendors like Trifacta, like Paxata, like Tamer. We've got self-service data integration going into BI tools, in Tableau, in Excel with Power Query. There's lots of this stuff going on at the moment. And I think the big concern within a lot of IT shops, certainly amongst IT professionals, is self-service data integration plus IT-based data integration going to end up like this? Is this just chaos? Are we just saying, let me at it, all bets are off, who cares? And so not only that, but all of these tools have got different metadata repositories, and before we know it, it's just beyond control. It's out of control and causing chaos within the enterprise. And so what I'm seeing, therefore, is the fact that we've got all of these different ways of doing stuff, but what's happening is we've got project-oriented data integration and data cleansing going on. The cost of data integration is too high with all of these tools. We've got metadata fractured across multiple tools. We've got people hand coding in Java, in Python to do this stuff where there's no lineage. We've got people reinventing all over the place, and we run the risk of multiple different versions of the same rules in different repositories and potential inconsistency just everywhere, opportunities to become inconsistent everywhere, and yet European Union is coming out with legislation around data privacy with extraordinarily high penalties, 20 million euros or 4% of your global turnover, whatever is the greater, is the penalty. If you're audited and found not to be compliant with the new EU legislation. This is stiff penalties. And so, the question has got to be, with all of this going on, is that it? Do we just have to live with this? Or is there a better way? Is there a way in which to bring all this back into a controlled manner? Lots of tools being out there, fine, but are they integrated? Probably not for many of us. And I think what we need is a lot more collaboration going on, So it's not enough to just kind of say, here's all of these technologies out here, let's go use them. We've got to get this under control, because for sure, everyone for themselves is not an option here, especially when regulation and legislation is breathing down our neck. So the question is there a better way? And I think there is. And so I want to talk about not a data lake, but a data reservoir. And why you might say, am I splitting hairs here and going for data reservoir? Well, the answer is kind of pretty clear to me. Water flows into a lake and doesn't really go anywhere, but water flows into a reservoir and goes through a process that makes it fit for consumption. And that's what we're trying to do here. We want this to become a place where we can produce value from. And so for me, a data reservoir is a collaborative environment. It's got to break the walls between IT and business down and invite people into virtual communities where they can work on producing data to add value to the business. So collaboration has to go into the software to allow us to do that. And we're already seeing that. Vendors like Tamer, for example, have added some kind of capabilities in there. And I think it's inevitable that others are following suit. I think Informatica in their latest release is also heading down a similar road. But it's not just any old community or one monster community. We've got to organize ourselves for success. And I think that means that we've got to take these projects and put them onto a hook that makes sense to a business, like a strategic business objective. Going back to our business strategy, what is it you're trying to do? We're trying to improve customer engagement, trying to reduce risk, trying to optimize business operations. So what are the information producing projects that are associated with customer engagement, or that are associated with optimizing business operations, or that are associated with reducing risk? And is it just that the data lake is only for Hadoop users? Or is this data reservoir to produce master data, to produce data for data warehouses, to produce data for sandboxes in a data science environment? Isn't it all of it? Now, clearly, if data comes into a data reservoir, we want to be able to classify it in order to understand how to govern it. But when you look at classification, you can't expect IT professionals to just figure that out. I mean, there has to be collaboration amongst the necessary combinations of the right people in business and IT to do this. And so when it comes to classification, there are different kinds of classification. There is, well, how long do I want to retain this information for? How long do I want, is this information sensitive in any way? But there's different levels of sensitive. What about confidence in the data in terms of quality? Is this completely raw data? Is it trusted data? What about business value? And all of these are potential tags. I could tag a file or even a record as confidential or as PII. And in which case certain policies may apply based upon how you choose to classify it. But equally, if I classify it as raw data, then there may be different data quality policies that apply to that. So there's different categories, different types of classification schemes that need to be introduced here. And so the kind of data reservoir needs to take on a new set of requirements. It's got to be able to allow collaborative data governance. We've got to be able to get the ability to categorize data in order to be able to, have I skipped over one? Sorry, yes. We've got to be able to automate the discovery and formatting of data when it comes in. We've got to, if possible, use analytics to even infer its structure. Maybe even go as far as to start parsing data and pulling data out that could be potentially of value, like monetary amounts or locations or addresses or product names or people's names or company names. We want the ability to automatically catalog this data, to be able to then offer up classification using these kinds of schemes, and be able to collaboratively work out what it is in terms of data quality and data trustworthiness and so on here, and on also to be able to refine the data, to be able to systematically clean it up and take it through various stages in order to make it available, and then ultimately to make it available for consumption, whether that's by business users, whether that's by data scientists in particular sandboxes. We've got to be able to kind of produce that. So for me, the data lake is not a single Hadoop cluster. How many of you have got more than one Hadoop cluster already? One data lake does not equal one Hadoop cluster, in my opinion. The data lake is distributed. That is to say, there are multiple Hadoop clusters, of which there could be all kinds of data sets in here, some of them trusted, some of them not. There's cloud storage. We've got multiple data warehouses. we've got master data, we've got reference data, and we need some way in which to get our arms around that and understand what's in that in order to be able to govern it and manage it. And that means, data is being collected in all kinds of ways across the enterprise. Could be across different geographic boundaries, or if you're only operating within a single country, just within that country. But nevertheless, the idea that it's all flowing to one centralized location is not necessarily the case. But if this is the case, then we need to know what's happening across this distributed landscape, which means that we have to have some way in order to be able to know what's going on, know who's doing it, know what purpose, what's the reason they're doing it, and for what business purpose. And that really means that we can't just have silos. We've got some mechanism that needs to allow us to do that. And that's where I see the emergence of information catalog technology to be able to handle that, so that we can go somewhere and find out what the status of data is within this distributed data reservoir, if you like. But it also has a bigger requirement, and that is it's not just an information catalog. We need a whole suite of data management tools to wrap its arms around this distributed data reservoir. That means the software has to move from not just being able to run on one place, but be able to run in multiple places, or even to run in a distributed fashion across a distributed data landscape. So what we need is define once, execute anywhere. But I really would like centralized metadata, or at least a virtual view of data in multiple places, metadata in multiple places, that looks like it's centralized. And I want potentially distributed execution. So for me, the data reservoir may be distributed, but we have to be able to manage it as if it was centralized. And that's a whole set of new requirements. It takes us into the world of having to be able to produce information and consume information. It takes me back to Henry Ford and a production line of information producers and information consumers. And all the way along the production line, people take what somebody's produced, pick it up, and consume it and produce something else. And so we get into the ability to take raw data, to go through various stages of production. So some data is in progress, all the way to data is ready to go in a trusted format, ready to be able to consume it. And so it means we've got to get into looking at a distributed data reservoir environment with some mechanism to understand the stages in which data must flow. And for me, that means we need some kind of zoning going on here. And the question is, well, how do you get zones on a distributed data environment? And the answer is tagging. We need to be able to tag the data so that we know what zone it's potentially in. And people will be working within these zones. On up one end of it, data is being ingested, but it doesn't necessarily mean it's being ingested into HDFS. It could be being ingested and held in the cloud, in cloud storage. Why should it be that HDFS is the only place where data can go? I think it's a bigger problem than that. And up the other end, we want a data marketplace, a kind of like inside the enterprise, I want data available as a service. So I can just order it and know that it's trusted and it's ready to go. But something has to know about, well, what zone's this data in? What state is it in? And for me, I think what we're seeing is that the catalog is becoming the place where that is. It tracks what's going on across this landscape. And it's pretty clear when you listen to the discussions around Atlas here at the conference and talk to some of the other information catalog vendors, that we're extending this. And it's not new. If any of you worked with portal technology in the late 90s or early 2000s, we had information catalogs there for content. SharePoint, for example, WebSphere portal server, Oracle portal, all were in this game of tagging content and building taxonomies. And here we go again on data to do the same thing again on data. But for here, we have to have an information production process in this production line. You know, we want to nominate data, even if we haven't ingested it yet. It might be open government data that's out there that we know that's of interest, but we want to bring it in. I haven't done it yet, but we'd like people within the enterprise to be able to nominate it. Yeah, then we'd like to be able to maybe ingest it into an ingestion zone, whether that's a cloud, whether that's HDFS. It shouldn't necessarily matter. The software should allow us to do it. And then we need to be able to tag it or auto-tag it to speed that process up. And once we have it in there, then we can classify it and say, well, you know, is this, you know, what degree of sensitivity is this? Or, you know, what kind of retention do we want around this data? And then we want to be able to then, on the basis of the classification, then we can assign different governance policies to that data. And then once we've figured that out, we can publish it into some kind of raw data zone where it's going to go through this process of making it fit for consumption. And then from there, we can pull data from a raw data zone, from trusted data zones. You know, if I archive trusted data out of a warehouse into Hadoop, shouldn't it still be trusted? If it's highly sensitive data in the data warehouse and I bring it into Hadoop, shouldn't it still be protected? I mean, I've got an obligation there. If I bring master data out of an MDM system about customers into Hadoop and it's highly sensitive, shouldn't it still be protected? Yes. I mean, the policy should still apply. So there are trusted data that we need to use to put raw data into context, in which case we may be refining that data and integrating it. And then we can collaborate about that. We need collaboration in here. During that process, we want to be able to track metadata about the freshness of this data. And then, you know, maybe we'll want to analyze it. Maybe it is sandbox material and it's going to go into data science and produce new kinds of insights. And then out of that, we're going to publish high-value data or high-value insights, you know, which then may have to go through one final stage of approval, maybe to map it into a common vocabulary. And then once we get it there, then we can approve it and publish it fit for consumption by others who need to access it. And then, of course, others should be able to consume it. Oh, and by the way, once they consume it, can they go back and rate the thing? TripAdvisor? Say, well, actually, this data is not that great. Or this data is really good. It's helping us, you know. So we get this whole collaboration thing going throughout the distributed data reservoir environment. And again, the catalog becomes the center of where all of this kind of metadata starts to become recorded. But all over this data reservoir, there's workflows. The data workflows for ingestion. We've seen NiFi talked about already last few days. You know, you've got workflows associated with moving, with refining data, with analyzing data, with publishing data, with provisioning data. And everywhere you look out there on the exhibition floor this week or anywhere else, you just keep seeing workflow. They're all doing it. Everybody's releasing workflow tools. And so the question is, how are we going to know about what's going on in all of these workflows if they've all got their own repositories and nobody speaks to each other? The answer is you're not going to know unless you go and connect to all of those metadata repositories, or is there a way to collect the metadata and bring it in? But there's a bigger problem, which is who's using which tools. Oh, and by the way, is anybody reinventing? Is anybody preparing data here, and they're doing it 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 here? Are they doing the same data again and again and again? Well, you know, is there not a better way? I mean, is there not a way to kind of deal with that? And so when you go back into the reservoir and you kind of think, well, is it always efficient to do everything by workflow, but could we not maybe substitute or convert the metadata that's being captured to do those jobs and turn some of them at least in, you know, from self-service data integration workflows into virtualization, data virtualization views. And so what I can then do is remove some of the complexity and replace physical intermediate data sets with virtual ones and keep a lid on the chaos and stop it proliferating out of control. And then if somebody else needs that data, they don't go and reinvent. They already find a new virtual view with that data in it and can go and get it without having to redefine the metadata. So I think data virtualization has a big part to play in a distributed data lake, and not something I've seen anybody talk really about this week. But I think for me as well, the information catalog is really becoming a central component. And we've now got information producers and information consumers in this production line in a distributed data reservoir environment. So what we've got here is people who are IT professionals producing data. Could be physical data sets, or it could be virtual data sets if they're doing it with data virtualization. Equally also, we've got data scientists, for example, producing data, or going to the catalog and saying, well, what already exists that's already produced so that I can consume it and not have to do that work all over again. And equally, we've got business analysts wanting to come into the catalog and say, well, what stuff already exists here that I can pick up and reuse? And then order that information, order that data, either to be provisioned to them in a range of different ways. So we kind of want the ability to kind of take raw data wherever it's captured, whether it's on cloud storage, whether it's on HDFS. We want to be able to crawl that kind of like Minority Report. Anyone has seen that movie, Minority Report, with what's his name? Yeah. So the crawlers, where they release them out running all over the place, looking in people's retina, right? So that's what we want to do here. We want to crawl this stuff, understand what's there, and publish its existence and understand it. We want the ability for people to then look in an information catalog, pick it up and prepare that data, and then publish it again. So that what's being published is already prepared data. It might only be just out of a single data source, but it's trusted, and then other people can pick that up and integrate it, and then publish that. And then what we get is trusted integrated data as a service, and then other people can pick that up and analyze it, and then publish that. And now what we get is already analyzed analytical pipelines, reusing as we go along. And so what's happening here is that we're getting faster at processing the data by facilitating reuse and leveraging the catalog along the way. So we get to the point where stuff may just be available and other people can just come in and access it. But the point is that we can get into a kind of production line of publish and subscribe throughout a distributed data reservoir and ingest data. Maybe have automated discovery and profiling of that data when it comes in, or if it's unstructured documents, then cluster the documents. And then we can choose if some of these clusters are irrelevant, we can throw them away and run with one of those clusters and do further text analytics and graph analysis and whatever we need to do on it. And we want to be able to catalog and tag those files. And again, place we're going to do that is in the catalog. But if the catalog is able to see across a distributed environment, there's no reason why it shouldn't. We've seen discussion about a need for Atlas to go across multiple Hadoop clusters. I think Atlas should go across multiple Hadoop clusters plus data warehouses, plus MDM, plus reference data management. Why should it stop at just Hadoop? Not all data is there. And I want to collaborate when data is brought into the enterprise anyway to discuss this data. Is it any value? Should we throw it away and pull other stuff in from open government websites because this data set that we've picked up isn't really much value? We need people to get involved in that process. And we have to break apart this problem. This is from IBM, which shows you that the fact that what we can now do is break apart, based upon classification of data, we can then assign policies And we talked about policies being attached to tags and different governance rules around that. So that we can associate different governance rules with different kinds of data. And then we can have governance-aware engines apply those rules at runtime in a dynamic fashion or even on an event-driven basis. So for me, the data refinery within this distributed data lake should really be taking complexity away. It should really be saying the software should be able to choose where it's best to refine the data, whether that's in Hadoop, whether it's in a data warehouse, whether it's on the cloud, or whether it's through data virtualization. It should choose. It's like a relational database takes queries and the optimizer chooses how to get you the data. What I think should happen here is that the software, the data management software, should have an optimizer and say, where is it best to process this data, and choose to do it. Whether it's on the cloud, whether it's on premises. And if it's in this distributed data lake and I want to run it, well, where do I run it? I can run it in Hadoop, I can run it in Spark, or whether it's on a Spark cluster on its own or within Hadoop on its own, with Spark on Hadoop. I could run it inside of a massively parallel relational database in the cloud environment. And it could be that, I have, what I want is centralized development, distributed execution. And I've got the ability to be able to do that. And it's pretty clear we're seeing several vendors heading in this direction now. I can think of the early stages of Informatica with Vibe, for example, trying to go after this. What's also interesting, however, is that not only is there just an IT user interface to this data, but to these tools, I beg your pardon, but there could also be a business self-service user interface to the same tool. That is to say, two different UIs to the same metadata, which would allow you then, at least if a business user defines something, IT professional could pick it up and see it. If an IT professional defines something, business user could see it. So if an IT professional prepares data, publishes it, business user can see it, reuse it. If a business user prepares data, publishes it, IT professional can see it, reuse it. So the power of shared metadata is very, very important here, I think. But what happens about this problem? What happens if data is too big to move? I had that with a client recently where they said they figured out that we were collecting sensor data all over the world, and what they found was they calculated that 24 hours of data would take them longer than 24 hours to pump to the middle. So the data is too big to move. And so they were forced into a distributed data lake environment because of that technical issue. The bigger issue for me is, what about conflicting jurisdictions with data privacy, which could easily keep data separated far more than technical reasons like being too big to move. But if we are in a situation like this, why would it make sense to try and bring all the data to the middle? When legal jurisdictions may prevent you from doing it, or size of data may prevent you from doing it, could I not take the tasks and push it to where the data is? I mean, what have we been talking about with Hadoop for ages? We've been talking about, don't take the data to the analytics, take the analytics to the data. Well, why don't we do the same with data management tasks? Push it down. And so that we can run this in a distributed environment. And so refining data has multiple options. I can use IT ETL tools. I can use self-service data integration. I can have tool suites with multiple user interfaces for IT and for business. I can use data virtualization, or I can use a combination of this. And I can bet that all of you out there have got something of this nature rather than coding it all yourself. So what we're seeing with ETL is those tools, vendors started generating HiveQL, then they migrated to generating Pig, then they migrated to generating 3GL Java for MapReduce, and then we went to Spark, and so we generated procedural language code for Spark. whether it's Python or Java or whatever, or it could be a proprietary engine such as Informatica Blaze or such as IBM with Big Integrate and Big Quality, or SAS with their ETL engine, which runs on their own proprietary engine across a Hadoop cluster. But all of these are out there today. That's one option. We've got self-service data integration tools, some of which can do more than just prepare data, some of which can prepare and analyze data. And so all of these are out here as well, and available. And then there are some vendors trying to cover all bases. The Informaticas of the world, Talon starting to head down that road. Pretty clear IBM's trying to head down that road, where they're trying to give you self-service data integration on the cloud, on premises, IT professionals still using their environments, even tooling available to business analysts, not just data scientists, and trying to say, well, all of it should be hooked into the same metadata repository. That's all from one vendor. That's a strategic investment. But what happens if it's too late? What happens if you're already beyond that and not just one vendor? Of course, if it was a single vendor, then what they've got is a service-oriented architecture within their own data management tool set. So they've got different kinds of users able to use the same tool suite on the same metadata to do any of these: data warehousing, MDM, big data, data preparation, cloud data preparation, all of it. But if you're already heterogeneous, that is to say you've got data integration tools from multiple vendors. How many of you have already got data integration tools from multiple vendors? Wow. So you're already into fractured metadata across multiple tools. So the question is, can we get interoperability between all of these? And the answer right now for me is this is not done yet. It's not complete, you know. I mean, there's APIs on some vendors' tools, but you know, there's no true standard. And of course, the question is, well, what about Atlas? And of course, you know, Atlas is very, very powerful potentially, you know, but there's already clearly non-ODPI members refusing to cooperate here. And the question is, will they be steamrolled by Atlas or not? But clearly what we could do is collect metadata from a range of disparate metadata tools and bring that metadata to the middle. And then from there, we could then put some kind of catalog on top of it and be able to see what's going on across this distributed landscape. And you know, there are vendors out there like Metadata Integration Technologies, Inc. with metadata adapters all over the place. And you could connect to their hub and get at all of the metadata so that you could see across a distributed heterogeneous landscape. So it could be that you've got an information catalog which is part of a big tool suite. It could be that you've got a standalone information catalog technology like Waterline or something like that. Or maybe it's an Atlas one, that the business data catalog from there. But at the end of the day, we need to produce data that's fit for consumption out of this distributed reservoir environment. And so at some point, we're going to have to map into a shared business vocabulary that's published in a glossary so that we can use it more broadly across the enterprise. And I think, you know, that clearly needs to happen, and we need collaboration in order to make sure that that happens so that we can use that data downstream. But I'd like to also offer up another problem here. For the last 3 or 4 years, or maybe longer, we've been talking about forget about waterfall-based projects and go agile. And we've been into Scrum and all of these kind of sprint methodologies, and you know, take data into a staging area and then go from there into a data warehouse, and out of a data warehouse into data marts, and from data marts into cubes, and from cubes finally to the user. And we said that's a crazy idea. We need to ditch that and go and do agile. Well, if we're not careful, we're going to repeat the same mistake here and just keep flowing copies of data all the way through this. So for me, we really need agility. And why should I keep spewing out thousands of data sets across the enterprise and trying to keep them all synchronized. Could I not put data virtualization in here? And so, if somebody says, well, what information exists about? Well, where are they going to find that? They're going to find that in a catalog. So they can search the catalog, see if it's trusted, see the lineage, maybe order it. So it's kind of, whether it's Waterline or whether it's the new Atlas catalog. I don't have any screenshots, so that's the reason they're not on here. But it's an Amazon style. I want to search my taxonomy, zoom in on what I'm looking for, put it in my shopping cart and order it. So for me, we're about to go here, where in comes the masses of your business users and says, give me it. Now, if you're going to distribute lots of data sets all over the enterprise for them to go and use, how on earth are you going to track that? And know that it's safe, it's protected, it's governed? Would it not make more sense to kind of say, well, if people order the data, actually be careful, because if they order it, they may not be allowed to use it. Maybe security would prevent them even seeing it in the catalog. That would be cool. But if they did order it, maybe because of different conflicting jurisdiction, we have dynamic application of governance rules coming in and saying it's runtime data governance. You've ordered this, but you're in this jurisdiction, therefore you can't have it all. You can only have this and not the full set. If the data's in Germany and you're somewhere else, you can't have it at all because you're violating legislation. And then the question is, should you give them it as a physical data set or should you virtualize it? And for me, I would virtualize it. I mean, it's so much faster to be able to spin up virtual views rather than just keep spewing copies of data out and trying to guarantee that the security is maintained across multiple distributed data stores when it's way out of your control. It's come out of HDFS. It's off in somebody's data mart somewhere. We could be more relevant if we virtualized it, I think. So there's a lot of stuff here to kind of take into account to organize a data lake. And if any of you are in San Diego next week at Enterprise Data World, I've got a whole day on this, never mind 40 minutes. But so for me, the challenge is now that we've got an analytical ecosystem. We've got to be able to look across a distributed environment, not think about just centralized one. It's pretty clear already that several of you have got multiple Hadoop clusters plus multiple data warehouses. So we're already in a much more complex state for data governance and data management than we've ever been before, with new data pouring in. And we have to be able to organize this thing to prevent the chaos, which means that one of probably the most critical success factor, or two of them. One is you have to organize yourself for success and not just look for technology to help you. And two is we need centralized metadata. Somewhere along the line, we've got to centralize the metadata, or at least give me a virtual view of distributed metadata that looks centralized. Hadoop's becoming a platform. We can accelerate it is a platform. We can accelerate ETL processing over there. A lot of people doing that. But it's not the only place. We've got, I have customers with hundreds of ETL jobs. They're not going to migrate them all to Hadoop overnight. So, the ideal situation here is that you'd have a sort of single view of the whole landscape. But for me, I think information catalogs are going to be absolutely critical going forward, and I think data virtualization is also going to be critical going forward. So sorry that's been a bit of a rush to wrap up, but I've got the hook signal from the back. So if you've got any questions, happy to answer those either now. Have I got a few minutes for questions? Time is up at the back. Well, we'll take a few questions while I'm bringing things down, and if necessary, we can go out afterwards at the end. Yes, sir. Thank you. Thank you.